Welcome to clickmyproject.com. Now we are going to see the paper on efficient formulation of the improved visual assessment of cluster tendency algorithm. The main concept of the paper is clustering. Clustering is the process by which the natural grouping are determined such that the objects in each group exhibit more similarity to one another than to objects in other groups. Clustering has also been called exploitative data analysis, unsupervised learning, numerical taxonomy, and partitioning. Clustering is typically thought of as only the act of separating objects into proper groups. Cluster analysis actually consists of three questions: cluster tendency, partitioning, and cluster validity. Most clustering algorithms require the number of clusters as an input. Cluster tendency is an important problem in cluster analysis. The visual assessment of cluster tendency, called iVAT algorithm, addresses this question by reordering the dissimilarity matrix so that ideally the number of clusters is displayed as the number of dark blocks along the diagonal. Recently, an improved iVAT called iVAT algorithm was proposed which first transforms D using a graph theoretic distance transform. Then VAT is used on the transformed dissimilarity matrix. Thus, the iVAT algorithm can be interpreted as a feature extraction technique. The example shown in suggests that the iVAT significantly improves the contrast of the dark boxes in most VAT images, resulting in an easier determination of the cluster tendency. In this paper, we present an efficient formulation of the iVAT algorithm which significantly reduces its computational complexity. Our iVAT implementation begins by finding the VAT reordered dissimilarity matrix and then performs a distance transform on this matrix. The VAT algorithm is a visual method for determining the possible number of clusters in or the cluster tendency of a set of objects. To improve the clustering accuracy, we present SEO VAT algorithm, and to improve the effectiveness of the iVAT, we present an efficient formulation of the SEO VAT algorithm which reduces the computational complexity. We have an m cross n matrix D and assume that its entries corresponding to pairwise dissimilarities between m row objects OR and n column objects OC, which taken together as a union n is equal to m plus n objects. This paper develops a new visual approach that applies to three different cluster assessment problems associated with O. The problems are the assessment of cluster tendency among the row objects OR, amongst the column object OC, amongst the union of the row and column object OR union OC. The basis of the method is to regard D as a subset of known values that is part of the larger unknown n cross n dissimilarity matrix and then impute the missing values from D. This results in estimates for three square matrices DR, DC and DR union C that can be visually assessed for clustering tendency using SEO VAT algorithm. Finally, we improve the clustering tendency using this SEO VAT algorithm. This is the flow of this process. First, we get 2D objects datasets. Each dataset is composed of a large number of 2D objects. After that, 2D objects can be visualized using 2D data plots. After the visualization, we are going to calculate the dissimilarity matrix between each 2D objects. Compute dissimilarity matrix from input 2D objects data. After calculate the dissimilarity, we are going to display the matrix using dissimilarity values. Next, we get all row objects data from 2D objects. Compare one row object into remaining all row object data and calculate the similarity between each row object. Get highest row object similarity values and form into cluster. Build cluster for row object using iVAT algorithm. The next process, get column objects data. Get all column objects value from 2D objects. Then we calculate the similarity between each column object value. Compare one column data object into remaining all column data object and get the highest column object similarity value and form into column cluster. Build a cluster for a column object using iVAT algorithm. Then finally, we combine this row and column object clusters. We get first dissimilarity matrix value and row object cluster and column object cluster. We combine these all values using COVAT algorithm. Is called SCOVAT. Finally, we define the cluster and visualization. The object visualization removes all noisy data and it improves the clustering accuracy and tendency. Next we see the running procedure of this process. First open the NetBeans, then open this process into NetBeans. Then click get object.java and click run file. First select the input 2D object data. Then click view button. These are the 2D objects. Then click plot object. This is the input representation of this 2D objects. Then click dissimilarity. First we are going to calculate the dissimilarity between each objects. Then click row object. Then we are going to calculate the similarity between each row objects. Click the cluster button. Using this similarity calculation, we cluster the row objects. Then click view. Totally the row objects have 4 clusters. Okay. Then column object clusters. First calculate the similarity between each column objects. Using this similarity, we are going to cluster this column objects. The column objects totally have 3 clusters. Okay. Then next process is combine this row and column objects. The combined cluster totally have 6 number of clusters. Then click view button. We are combined both row and column objects and a dissimilarity between each 2D objects. Then click display button. This is the final view of the input. The final output totally have 2 clusters. Remaining noise data are removed using this algorithm. Thanks for listening.